Hello everyone, this is your Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem. Form partial differential equation from z equal to f of 2x plus y plus g of 3x minus y by eliminating the arbitrary functions f and g. We are given a relation and we are asked to form a partial differential equation by eliminating this f and g. Let's see. Given z equal to f of 2x plus y plus g of 3x minus y. Consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of the equation. This gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Partial derivative of f of 2x plus y with respect to x is f dash of 2x plus y into inner derivative dou by dou x of 2x plus y plus partial derivative of g of 3x minus y with respect to x is g dash of 3x minus y into inner derivative dou by dou x of 3x minus y. Since we know that dou z by dou x equal to p, we can just replace it by the notation p. We'll get p equal to f dash of 2x plus y into 2 into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus g dash of 3x minus y into 3 times partial derivative of x with respect to x is 1 minus partial derivative of y with respect to x is 0. This gives us p equal to 2 into 1 2, 2 plus 0 2, 2 f dash plus 3 into 1 3, 3 minus 0 3, 3 g dash. Consider as equation number 2. Now let's partially differentiate 1 with respect to y. Now let's partially differentiate 1 with respect to y. Okay? Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. So it is not necessary to apply dou by dou y all the time, but you may make mistakes, okay? Just to make them understand, and also in order to avoid mistakes, we are taking dou by dou y or anything dou, partial derivative operator, okay? Just to avoid mistakes, we are taking it. If you feel it's unnecessary, you can just skip it. You can just avoid it, okay? This gives us dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant, and also we'll use the notation dou z by dou y equal to q, right? The partial derivative of f of 2x plus y with respect to y is f dash of 2x plus y into inner derivative dou by dou y of 2x plus y, and also you can skip this step, okay? It's not necessary to write this, but many people will not understand or don't know to find the inner derivative for them. For the sake of those people, I'm doing it. Plus partial derivative of g of 3x minus y is g dash of 3x minus y into inner derivative dou by dou y of 3x minus y. As I said earlier, you can just replace it by q. You'll get q equal to f dash of 2x plus y into 2 in partial derivative of 2x with respect to y is 0 plus partial derivative of y with respect to y is 1 plus g dash of 3x minus y into partial derivative of 3x with respect to y is 0 minus partial derivative of y with respect to y is 1. This gives us q equal to 0 plus 1, 1, 1 into f dash is f dash. 0 minus 1 is minus 1, minus into plus minus, 1 into g dash is g dash. Now consider it as equation number 3. Now we got equation involving q, that is f dash of 2x plus y minus g dash of 3x minus y, which is our equation number 3. Now let's find the equation involving r. Okay, here r is nothing but dou square z by dou x square. You can write dou square z by dou x square as dou by dou x of dou z by dou x, right? Since dou z by dou x is nothing but p, so by partially differentiating equation involving p with respect to x gives the equation involving r. So what we'll do is we'll just pick the equation involving p, which is equation 2. Now we'll partially differentiate equation 2 with respect to x so that we'll get equation involving r. Now let's partially differentiate equation 2, it's 2, okay, with respect to x. Just apply dou by dou x on both sides of 2. This gives us dou p by dou x, which is r, okay, and here we are partially differentiating with respect to x, so we'll read y as constant. We have constant 2 into partial derivative of f dash of 2x plus y is f double dash of 2x plus y into inner derivative with respect to x plus constant into partial derivative of g dash of 3x minus y with respect to x is g double dash of 3x minus y into inner derivative with respect to x since dou p by dou x is nothing but dou square z by dou x square, which is r. We can just replace it by r. We'll get r equal to 2 into f double dash of 2x plus y into 2 into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus 3 into g double dash of 3x minus y into partial derivative of x with respect to x is 1 minus partial derivative of y with respect to x is 0. This gives us r equal to 2 into 1, 2, 2 plus 0, 2, 2 2s are 4. You will get 4 f double dash. 3 into 1, 3, 3 minus 0, 3, 3 3s are 9. You will get 9 g double dash. Okay, which is our equation number 4. Right, we got equation involving r, that is r equal to 4f double dash plus 9g double dash. Right, this is our equation number 4, right? Fine, now let's find equation involving s. S is nothing but not st. If necessary only we'll find s. I mean equation involving s. Otherwise it's not necessary. Okay, now let's find equation involving t. Here dou square z by dou y square can be written as dou by dou y of dou z by dou y. Dou z by dou y is nothing but q. So I'll get, which is dou q by dou y. So now pick equation involving q, which is equation 3. By partially differentiating equation involving q with respect to y gives equation involving t. Okay, So now what we'll do is we'll just partially differentiate 3 with respect to y so as to get the equation involving t. Partially differentiating 3 with respect to y. Just apply both sides of this equation by dou by dou y. Okay, just apply dou by dou y on both sides of 3. This gives us dou q by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant, and partial derivative of f dash of 2x minus y with a 2x plus y with respect to y is f double dash of 2x plus y into inner derivative with respect to y minus partial derivative of g dash of 3x minus y with respect to y is g double dash of 3x minus y into inner derivative with respect to y. Since dou q by dou y is nothing but t, actually it is nothing but dou square z by dou y square, which is our t. Okay, you can just replace it by notation t. You'll get t equal to f double dash of 2x plus y into partial derivative of 2x with respect to y is 0 plus partial derivative of y with respect to y is 1 minus g double dash of 3x minus y into partial derivative of 3x with respect to y is 0 minus partial derivative of y with respect to y is 1. This gives us t equal to 0 plus 1, 1, 1 into f double dash is f double dash. 0 minus 1, minus 1, minus into minus plus 1 into g dash is g dash, g double dash. Consider as equation number 5. We got equation 5 which is involving t. Now observe all these equations. We have p equal to 2f dash plus 3g dash. You can't take anything common. And here you have f dash minus g dash. And in R you have 4f double dash, 9g double dash. Here you have f double dash plus g double dash. So the possibility of finding PD using these equations is, using these equations is very less. So let's find S, equation involving S, and let's see what happens. Okay, trial and error. We don't know exactly what it happens, so we just observed and we got to know that it is not possible to find partial differential equation using these 5 equations. So now we are going to give it a try for this S. So you can write this in 2 ways, that is dou by dou x or dou z by dou y or dou by dou y of dou z by dou x, right? We all know this, right? Fine. And also here dou z by dou y is nothing but q, right? So dou q by dou x is our S, fine. And here dou z by dou x is nothing but p, so dou p by dou y will be S. Either you can go for dou q by dou x or dou p by dou y. What I mean is S is nothing but dou q by dou x or dou p by dou y, both. So you can find equations using any of these two. Okay, if you want you can try the other. I'll go for this. You can try this and let me know the answer. Fine. Here you have q, right? Now pick the equation involving q. So this is the equation involving q, which is equation number 3. Now if you partially differentiate both sides of this equation with respect to x, you'll get the equation involving s. Let's see. partially differentiating three with respect to x. Just apply dou by dou x on both sides of 3. This gives us dou q by dou x equal to partial. Here we are partially differentiating with respect to x, so that we'll treat y as constant. Okay. Now partial derivative of f dash of 2x plus y with respect to x is f double dash of 2x plus y into inner derivative with respect to x minus partial derivative of g dash with respect to x is g double dash into inner derivative, that is dou y with respect to x, inner derivative with respect to x. Since dou q by dou x is nothing but s, replace it by s, since dou q by dou x equal to s, okay, which is a notation. We'll get f double dash of 2x plus y into 2 into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 minus g double dash of 3x minus y into 3 times partial derivative of x with respect to x is 1 minus partial derivative of y with respect to x is 0, which gives us s equal to 2 into 1 2, 2 plus 0 2, 2 into f double dash is 2f double dash, 3 into 1 3, 3 minus 0 3. We'll get minus 3 into g double dash of 3x minus y. Okay, fine. Now we got s. Consider it as equation number 6. That is, we got equation involving s here, right? We got s equal to 2f double dash of 2x plus y minus 3g double dash of 3x minus y. Right. Now we are going to use our brain. Fine. Now observe 4, 5, 6 equations. Okay. You have to observe clearly. You have 4, 9, 1, 1, 2, minus 3. Right. Fine. If you do r plus t, you will get 4 plus 2, 6 f double dash. 9 minus 3, 6g double dash, right? Fine, very good. You got 6 f double dash plus 6g double dash using r plus t, right? And in this equation, you have 1, 1, right? F double dash plus g double dash. So, you can multiply 6 on the both sides of the equation, so that you will get r plus s minus 60 gives something. Let's see that. Okay, I'm doing r plus s first. Okay, r plus s gives plus s. Right, which gives us 4 plus 2, 6 f double dash, 9 minus 3 plus 6 g double dash, right? Take 6 common from these two. We have seen this somewhere, right? It exists in equation 6. F double dash, okay, equation 5. F double dash of 2x plus y plus g double dash of 3x minus y equal to t by equation 5. So just replace this by t, you'll get 60. Now bring this to LHS, which is the required partial differential equation, right? Or in some books they directly did like r plus s minus 60. You can just do it, okay? By looking at this, we can say that it gives 0. 4 plus 2 is 6, right? 6 f double dash of 2x plus y. 9 minus 3 is 6. Minus 60, 6 times t, minus 6 f double dash minus 6 g double dash. This gives 6 f double dash minus 6 f double dash gets cancelled, plus 6 g dash, g double dash, and minus g double dash gets cancelled, and finally you'll get 0. Just by looking at these three equations, we can say that, okay? Or you can just do like this. Therefore, r plus s minus 60 equal to 0 is the required partial differential equation. So this completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye and thanks for watching.